Section 7.3.2, Recon with Scanning, Part 2. The command we see here is broken into 4 parts. We have the command of what we want to do with the nmap, the option for the scan, the network ID, and the submask. What we are asking this to do is a host discovery scan, which will send packets to all IP addresses in the 192.168.100.0 network with the subnet mask of 255.255.255.0. Remember, the /24 means there are 3 255s. A basic nmap host discovery scan is often called a ping sweep because it replaces the manual method of sending a ping packet to all IP addresses. In actuality, the nmap-sn command will send ARP requests to every IP address on the network. A live host means these are systems that are on and they respond to scan packets. When you do send out scans, you should consider if the scan will be noisy or attract attention. We can see exactly how nmap works by examining a Wireshark capture of the packet activity. The sender is 10.10.10.5 and is scanning the network by sending ARP request packets to every IP address in the 10.10.10.0/24 network. This is a truncated look at the whole scan, which will try IP addresses from 10.10.10.1 all the way to 10.10.10.254. Nmap will report that 3 hosts are up, and in the Wireshark capture, we see Nmap gathered that information because 3 devices have replied, which means they are live. This also means that they are connected to the network and turned on. Those replies came from 10.10.10.1, .4, and .6. Here's the problem with doing scans on a network. If someone is monitoring the network with a tool like Wireshark, then they will definitely notice an ARP request going to 254 network addresses in sequential order. That's not normal traffic on a network. To address this, Nmap has lots of different options, and many of them will help make your scan more stealthy. Remember, the scan is part of Recon before trying to exploit the network. If the target sees a scan, they will be aware that someone is performing Recon and will probably take action to be more secure. Malicious actors don't want that. When people think of Nmap, they most often think of this feature, knocking on ports to see if they are open. To exploit a system, I am going to need a way in. The easiest way is to find a service that is running to provide a service to the outside world. Port scanning is a technique used to send TCP and UDP packets to various ports to determine if a service is active. A web server is the best example, but there are lots of other servers that must interact with the public. Think about it. A door that is used by lots of strangers should be easy to sneak in through, as opposed to doors that are private and need ID to get in. So doing a port scan is the way to find those devices. But as we just said, going through the whole 3-way handshake to complete a connection is going to attract some attention if you try to do it to every system in the network. And while a TCP connection scan is the most reliable, it is also the most noticeable. It is easily logged and detected because a full connection is established. It uses the nmap-st option where open ports respond with SYN-ACK and closed ports respond with RST-ACK. This Wireshark capture of a TCP connection scan shows that the sender 192.168.1.105 is scanning a target by sending SYN packs to 192.168.1.5 for different port numbers. Let's look at this for a moment. Which 4 ports are open, and how do we know? We see a reply from open ports that have the SYN-ACK reply, so we know that the following ports are open: HTTPS from row number 17, FTP from row 18, SMTP from row 19, and NetBIOS SSN from row 23. Which ports are closed, and how do we know that? For these, we get the reply of RST/ACK, so we know these ports are closed. So we know the following ports are closed: 22 on row 14, FTP data on row 20, and POP3 on row 21.